Hello students, today we are going to look at these exam questions on the board, the questions on electrolysis, which we discussed in our last video. Okay, in the last video, I told you that electrolysis is the chemical decomposition of a compound as a result of allowing current to pass through. Okay, of which I told you that electrolysis is coined from two words, which are electro and lysis. Okay, I told you that electro means electricity, lysis means breakdown. Okay, and I told you that electrolysis is the chemical decomposition of a compound as a result of allowing current to pass through. And I told you that this compound is constantly in molten form before they can conduct electricity. Then I call the compound electrolyte. Okay, same in that video, I gave you the law we use in solving calculations on electrolysis, which I called the Faraday's laws of electrolysis. Okay, and I told you that these laws are two, but we discussed about the first law of electrolysis, which is the law of Michael Faraday, and we are going to apply the law here in the question to solve this. Question number 1. What mass of magnesium would be obtained by passing a current of 2 amperes of 2 hours 30 minutes through molten magnesium chloride? Okay, and according to Michael Faraday, the mass is directly proportional to quantity of charges in coulombs. Okay, so the mass of substance liberated or deposited is directly proportional to the quantity of charges that passes through it. That means as the quantity of charge increases, the mass of substance to be liberated will be increased. So that means mass is directly proportional to the quantity of charges, which is in coulombs. We know that the quantity of charge here is in coulombs, and the mass here is in gram, since this is chemistry. Okay, the mass, if you remove this, you have equality sign, then K, Q. I told you that the K represents the constant of proportionality in the last video, and which is used to represent the electrochemical series. That is the charge in the electrochemical series. And here, what we have here is magnesium. Okay, the charge of magnesium here, magnesium ion is +2. That is the charge, +2 charge. Okay, by passing a current, the current here is represented with I. The current here is 2 amperes. Okay, for time, which is time here is 2 hours 30 minutes. That's the time through a molten magnesium chloride. Okay, then I told you that for standard, okay, mass equal to KQ. Now we now have the question here. The question here is the mass is equal to that quantity of charge. Okay, and remember, quantity of charge here, Q, is equal to IT. Are you following? So if Q is equal to IT, that means here, if you look at the question, we don't have Q here, but we have IT given. Q is equal to IT. That means IT will represent Q in this formula. So we now have IT, which is for Q. Remember, the K is not here. We use this K in the standard, and this is the standard given for us. Okay? Now, for that standard now, what is the atomic mass unit of magnesium? Atomic mass unit of magnesium is not in the question, okay? That is gotten from adding the numbers of proton and the numbers of neutron. We call it atomic mass unit, okay? And that is equal to 24 gram. is constant for every calculation you are working with magnesium. We call it relative atomic mass unit. For magnesium, it is 24. Now, mass is equal to this. So this mass for the standard here becomes 24, equal to Q of, this is the charge of magnesium here, which is how many now? 2. Multiplied by Q. This Q here is representing what? Faraday. And 1 Faraday for quantity of charge is 96500. Okay, then you are looking for mass. What mass of magnesium? This is the one you are looking for, which is this M here under the first M. This is what you are looking for, equal to IT. What is our I here? I here is what? 2 amperes. Then multiply by T. So we have to convert this whole thing here in seconds, because I told you that the time must be in seconds. Okay, now 2 hours. 1 hour here is equal to 60 minutes. 2 hours is equal to x. If you cross and multiply, our x is equal to 2 times 60 will give us 2 times 60. That is 120. Abi? 120 minutes. You add it to 30 minutes here. Is equal to 150 minutes. Okay? Now, since it's 150 minutes, remember 1 minute is equal to 60 seconds. Therefore, 150 is equal to x. Because your time must be in seconds, that is why you have to convert the 150 minutes here to seconds. So therefore, if you now cross and multiply, s is equal to 150 multiplied by 60. 150 multiply 60. That will give us 9,000 seconds. 9,000 seconds. Okay, so you come here, your time represents what? Your time represented by 9,000. Okay, so you now have to cross and multiply. 2 times 9,000 will give us 18,000. Multiply 24. That will give us 4,32000 equal to 2 times 96500. That is 193000x. Divide by 193000. Divide by 193000. This will cancel this part. Therefore, 432,000 divided by 193000. That will give us equal to, therefore s is equal to, this will cancel this, and that will give us 2.238 gram, because we are solving for mass, it's in gram. So you come here in the option, you have 1.12 gram, 2.00 gram, 2.24 gram, and 4.48 gram. And what we have here is 2.238. So this person here, this 8 here is up to 5. You have to call it 1 and add to this 3, and it will become 4. That is approximation. So it's going to be 2.2. This one is up to 5. You call it 1, add to this, it becomes 4. Abi 2.24 grams. So here, option C is the correct answer. Is that okay? Option C here is the correct answer. Let's go to question number 2. And the question states, what volume of oxygen at STP would be liberated on electrolysis by 9650 coulombs? That is 9,650 coulombs of electricity. The molar volume of gas is 22.4 dm cube. 1 farad is 96500 coulombs. This I told you in the last video. Okay, that mass, you can also use volume, right? We can also use number of what? Atoms, which I said is 6.02 times 10 raised to the power 23. Okay. We can also use mole to solve against farad, depending on what you are working with. If it's magnesium, it's 2 farad. If it's aluminium, it's 3 farad, because 2 is the charge of magnesium and 3 here is the charge of aluminium. But now, let's look at the question here. We are working with what? Oxygen. Okay, and oxygen, as we have here, is a diatomic particles and is also a divalent. Okay, so because oxygen is diatomic and is divalent, so it's going to liberate what? 4 farad. Diatomic, it can't exist alone, is 2. Divalent, it has what? Charge of 2. 2 times 2 is 4. So every 1 mole of oxygen in electrolysis will liberate 4 electrons. Okay, and that 4 here will represent the 4 Faraday, because we are working with the volume and Faradays as related with the first law of microfarad, where mass is directly proportional to the quantity of charges passing through it. Okay, so here we are working with volume, and this volume is 22.4 dm cube for 1 mole of any substance. Okay, so here is 22.4 is equal to 4 farad. 1 farad is 96500 coulombs. Okay, the what volume? You are looking for the volume that will liberate 9650. So what are you going to do next now? This, you multiply this, cross and multiply. Okay, so 4 multiply 96500, abi 96500 multiply x. What do we have here in the calculator? 4 times 96500, that will give us 386000x. You are working against 22.4 times 9650, which is this in the question. 9650 multiply 22.4 will give us 216160, divide by 386000, divide by 386000. This will cancel this. Then 216160 divided by 386000, that will give us equal to 0.56. Remember, this is in dm cube, 22.4 dm cube. This is the answer in dm cube. Okay, 0.56 dm cube. And the answer here is option D. This is the correct answer. Okay, that is to say 0.560 dm cube will be liberated by 96500. Okay, obeying the Faraday's law of electrolysis. Is that okay? Now, this is the last question here on the board. Here, you have to relate this silver with oxygen by doing first calculating the amount, that is the quantity of charge that will liberate 10.8 gram. Okay, you have to look for the quantity of charge that will liberate 10.8 gram of silver. Then you will now use that quantity of charge to solve for what? Oxygen. If 10.8 gram of silver is deposited in a silver calometer connected in series with a copper calometer, now the volume of oxygen liberated is dash. So you have to solve for the quantity of charge that will liberate 10.8 gram of silver. You will now use that quantity of charge that liberated this volume, this mass of silver here, to calculate the volume of oxygen that will be liberated. Okay, so at first, silver, the mass of silver is 108 gram. Okay, the mass of silver for the standard of silver here is 108 gram. Okay, and if you go to the electrochemical series, The charge of silver is plus 1 charge. That is 1 times 96500. It's equivalent as saying 1 Faraday. Okay, then here you have 10.8 against S. You are looking for the quantity of charge that will now liberate 10.8 gram of silver. So here you have to cross and multiply. If you cross and multiply, you have 96500 multiply 10.8. That will give us 1042200 abi against 108x. Divide by 108. Divide by 108. If this cancel this, s is equal to, s will give us 9650 coulombs. So this is the actual quantity of charge that will liberate 10.8 grams of silver. Now, we can now use this to calculate the volume of oxygen that will be liberated. Okay, oxygen, I told you, is diatomic, right? Oxygen is diatomic. Okay, but here in the question, we are not solving with mass. So we are not going to relate the diatomic aspect of it since we are working with volume. Okay, and as standard, 1 mole of oxygen, okay, we occupy 22.4 dm cube of volume, right? So here we have 22.4 dm cube against 4 Faraday. That is 4 times 96500. 96500. Then you are looking for the volume that will be liberated by the same quantity of charge that deposited 10.8 gram. Abi, this is 10.8. Then all over 9650. You have to cross and multiply again. 9650 multiply 22.4. That will give us 216,160 against 4 times 96500 equal to 386,000x. Divide by 386,000. Divide by 386,000. This we cancel this. X is equal to, if this divide this, that is 216,160 divided by 386,000. That will give us equal to 0.56 dm cube. Okay, we have that in the option 0.56 dm cube. That is option A is the answer. Okay, I believe this video will help you a lot when solving so many calculations questions in electrolysis in your past question. Okay, if there is anything you don't understand in the video, please drop your comments in the comment section. Okay, or if there's any aspect of calculations on electrolysis, please also don't hesitate to drop that in the comment section. Thank you and God bless you. Please don't forget to subscribe and share our video. Thank you.